variable to solve for would be x in the second equation, because all I have to do is subtract 2y from both sides. Or I could use elimination, because all I'd have to do is multiply the bottom equation by negative 3 in order for positive and negative 3 to get rid of the x. All right?
Yes.
If you multiply this bottom equation by negative 3, you get negative 3x plus 3x eliminates the x.
What we're doing, we need to solve for y.
Let's flip the eraser. Bottoms up, we're doing substitution. Tops up, we're doing elimination.
Yes. Substitution.
Bottom up, substitution.
Yes.
All right. So that means I've got, I got to put the eraser down. I've got 3x minus 7y equals negative 6. And in the second equation, if I solve for x, I've got this. If I know that x is equal to this phrase, I can substitute that phrase into the other equation for x. So 3 times 11 minus 2y minus 7y equals negative 6. Now I only have y, so I can figure out what it is. Distributing, I have 33 minus 6y minus 7y equals negative 6.
So that'd be like 33 minus 13y.
That would be 33 minus 13y equals negative 6. Subtracting 33 from both sides.
Negative 13 plus positive 3.
Negative 39. And when you divide both sides by negative 13, y has a value of 3. Now to finish off the cycle of substitution, if y equals 3, I've simply got to plug that in here to figure out x. So x is equal to 11 minus 6, or x equals 5. Remember, this is a point on a graph.
Wait, so how'd you get 39?
Wait, I thought you had to plug x back into the main equation.
There's only 2
Can we do
variables.
that for like everyone?
Okay?
I thought you have to plug y back.
That's so much easier than everything else.
No, you don't have to.
Wait, where did
You don't have to. Where did what?
Oh.
Okay?
Can you give us one with both?
No, just use that.
No, elimination's easy too.
No, I mean, like,
Yeah.
That's
3 variables?
That too.
whatever x is if I, like,
Okay.
one.
All right, let's do one.
Let's don't say
Shh.
it's so hot.
Y'all get quiet.
Sound.
What?
The answer was 5. No, last one.
I don't remember. Let me see. Okay.
Sally, is it possible we could?
Not really. But Aaron, can you go lower it and try?
Can we open a window or something?
Sure you don't want to switch it?
No. Shh. Y'all be quiet. Okay, let's say we wanted to solve this system. Substitution is not going to be as easy because I'm going to create fractions if I try to solve any one of those equations for any one of those letters. So if I'm going to use elimination, just choose a letter. Okay? I want these two numbers to become the same, but one plus and one minus. So I can turn them into 12. The way I'm going to do that is if I multiply 4 times positive 3, it'll give me positive 12, right?
Yes.
So I'll need to multiply 3 times negative 4 to give me negative 12. But that means I have to multiply everything by those numbers. Okay, so I have 12x. I'm taking the very top equation and I'm transforming it.
12x minus 15y equals the
51.
50.
Not when you have to create fractions. All right, so my x is gone. I've got negative 31y is equal to positive 31.
It's 20.
No, it's 31.
Wait, 16 plus 5.
16 plus 15. So y is equal to negative 1.
Wouldn't it be a positive?
Wait, wouldn't it be just 1?
Negative 15 minus
Oh, it's
16
Ah, yeah.
is negative 31, and 51 minus 20 is positive 31. So y is equal to negative 1. Take that information, put it back into either this, or this. Any one that you want. If I use the very top equation, if y is negative 1, then 4x minus 5 times negative 1 turns to plus 5 equals 17. Subtract 5 from both sides. 4x is 12. So x is 3. So 3, negative 1 was the point where those two lines intersected. Okay, let's move on. Be able to graph a linear inequality.
That would be y-intercept 4, slope 3 over 1.
Your slope is 3 over 1. Your y-intercept is positive 4.
What number is
I'm just making it up.
What was x for the last one?
Shh, y'all need to be quiet. X was 3.
Solid line.
We start at our y-intercept, which is positive 4. Our slope is to go up 3 units from there and to the right 1. Our line is solid because this does say equals to. And we shade above because the symbol is greater than. Now, how do we determine if it's above?
The little teeter-totter you showed us.
Right. If this line here were to flatten itself out, the shortest way to get flat is this way, right? This is your down region. As we flip it back over, trying to, not working very well. Above, I'm sorry. This was our above region. We want to shade above the line.
Start fired.
If it's vertical, you've got left and right.
If it's greater than shade,
Yeah, but like if the arrow's pointing right, then you should do right.
No, not necessarily. Okay.
Just think that it's like this.
Greater than generally means up. Less than generally means down. If it's vertical, there is no up and down.
Right and left. Vertical, the sign.
It's right and left.
left is
Okay.
greater than
So yeah, if it is vertical, the sign will tell you which way.
Yes,
Well,
like
put
positive.
If it's vertical, the symbol tells you exactly which way to go. But if it's not vertical, it's up or down. Now the way you figure out up or down is you imagine your line trying to level itself off, okay? Because it wants to be this way.
I got that.
Don't just look at the symbol and if it's pointing that way, shade that way. No,
No, it's only if it's.
only if it's
that's what I was
vertical.
wondering, like if it was vertical.
Only if it's vertical. Okay?
So less than's left.
if it's vertical, think of the numbers like these numbers are bigger. So that's
Exactly, you think of the number line. Okay, we also need to be able to graph.
We need to do those triple things.
Yeah, this is stuff.
This is bullets.
This is an absolute value inequality. It's a V. Remember, the slope is always found directly in front of the absolute value brackets. If there's no number there, it's understood to be 1. The vertex